Well, I was looking at the agenda for today's conference, and they're great speakers. They'll be going into a lot of detailed topics. And my objective here is to motivate a discussion about the sessions that you're about to see later today. You'll drill into a lot of information. Mahesh already talked about, and Magnus together talked about the sessions that are there on the docket. I just wanted to take a few minutes to motivate a couple of things. So here is my first slide, and this is my agenda slide. Quite unusual for an agenda slide to see a diagram, but these are the three things that I really want to focus on. And I have limited time, so I won't get into as much code as I would like to, but hopefully I can give you a sense for why this is important. So the three things that I want to focus on today, first is cloud native constructs. So what do I mean by that? And what does cloud native mean? And I'm sure you've heard of many terms. There is a whole foundation called the Cloud Native Computing Foundation, CNCF. There are a whole host of definitions about cloud native. I'll just give you my simple definition, which is, are you trying to build applications in the cloud that take advantage of the latest innovations and capabilities in the cloud, whether it is serverless, whether it is a managed Kubernetes environment, whether it is a consumption-based SQL server or a global database like Cosmos DB or something like that. The idea is that you're taking advantage of the latest and greatest innovation. Many of these services that we talked about, they've been designed with cloud in mind, whether it is multiple regions, failover capability, elasticity, and whatnot. So if you're taking advantage of those things, I like to call them cloud native constructs, whatever your definition may be. So keep that in mind, and we'll drill into that in a moment as well. So that's one. The second thing, which is becoming increasingly important, is consumption-based pricing. So what do I mean by that? As large companies are moving to the cloud, as they are moving their existing applications to the cloud, it is becoming very clear that now the next step of the journey is, how do we optimize our footprint in the cloud? How can we optimize the consumption in the cloud? Right? This is going to be really important, and there is a fundamental shift that this is happening. Right? It is fine for you to move to the cloud in a pre-provisioned capacity model. What do I mean by that? Well, I'm moving to the cloud and I need these many VMs, I need this much storage, I need this much compute capability or network or whatnot. I'm pre-provisioning that capacity. And of course, there's auto scale, don't get me wrong. I'll provision it to a certain number, and then I can auto scale up and down. Many applications can't take advantage of auto scaling because their business is consistent across the 24/7 time frame. May not be peaks. They may have some peaks, but it's consistently used. There are many applications that see episodic use, have few users in the morning and then nobody in the day, maybe in the evening. So you have to keep those systems up. And if you think of those in terms of consumption-based pricing, you are having to pay for all the time that you have reserved the capacity. And what we are finding now in 2020, that the option for only paying for what you use is becoming really important. And that's what I mean by consumption-based pricing. Only use resources and only pay for resources that you are using. Let me take a couple of examples to point this out. This has been around for a long time, but this is becoming more and more important. Let me give you a couple of examples. Everybody knows Azure Functions has a consumption-based pricing model, so you don't pay for a pre-provisioned capacity. You're paying for how many times you're invoking that piece of code. That's essentially what a consumption-based pricing is. But if you look at it today, Cosmos DB team has announced a serverless model. SQL Server in Azure SQL Database has a tier, consumption tier, where you run a query, and based on the kind of query that you're running, they can scale up the number of cycles they make available for your query to run efficiently. Take API management, for example. They have a consumption tier. So previously, We used to have, hey, provision an API management instance, and it gives you 2 million calls or whatever million calls it gives you. And customers are finding that, hey, I'm using 200,000 calls. I'm not quite using the quota. Should I be paying for that amount? Wouldn't it be nice if I could pay for the API gateway that works in a consumption based model where I only pay for the number of API calls I'm servicing? Okay, so that's consumption based pricing, very important concept. And I know you cannot move to consumption based pricing in all cases. And in some cases, a provision capacity would make it more cost effective, right? If you have a SQL server that is running at a consistent capacity for most majority of your month, then it might be advantageous for you to go with a pre-provisioned capacity. In fact, it might be advantageous for you to go with something called the reserved instances, where you say, Microsoft or Amazon or whoever, I want this capacity for a period of time. Please give me a discount for a long-term usage. It might make sense, but I want you to focus on consumption-based pricing. The third and final thing I want to talk about here really is developer productivity. So what do you mean by that? Well, so we can have cloud native constructs, we can have consumption-based pricing, but it doesn't really help us if we can't build these applications quickly. What are the sort of the developer productivity benefits that are coming out from the various teams, and how can we leverage that to build these applications quickly? So think about these three things as you are embarking on your journey in the cloud, or you're already in the cloud, as you're optimizing your presence in the cloud. Think of these three things as we progress further. Okay, so with that said, I want to go quickly to Vishwas. Now, you have talked about these three motivations: consumption, cloud native, and productivity. But before you go there, let me ask a question. Who's using the cloud? Why is it important for me to learn this? Can you tell me about it? And here's a slide. I took this from Scott Guthrie's keynote back in June and Build. More than 95% of Fortune 500 companies are using Azure public cloud some sort. So I often still get questions from people that I'm interested in the cloud, but I really didn't have an opportunity to work on it because my employer will not let me go to the cloud, or my customer is very concerned about the cloud. We want to demystify that. If 95% or greater Fortune 500 companies are using this, there's a very good chance that the use case that you're working on is probably be acceptable in the cloud. And of course, during my introduction, I talked about this earlier. I live in the Washington D.C. area. We do a fair amount of work on the Azure government space. And if some of the agencies which do classified work are going to Azure government and public cloud in general, there are very few use cases out there where you can say, I can't run in the cloud anymore. So I want to take this back. Here's another slide very quickly. This slide is, again, gives you answering the question, who's using the cloud? Well, if Microsoft was not seeing this kind of adoption, they won't be creating these new regions, including the one in New Zealand. You can see at the bottom right, brand new region, 61 regions and growing. And the interesting number is that it's a worldwide presence. This is more than AWS and Google combined. Pretty interesting statistic. Okay, so we've talked about who's using the cloud, and why should you be, and what are the kind of customers. The next thing we want to talk about is, so Vishwas, you said cloud native applications, and you talked about consumption based pricing, and you talked about Azure functions. That sounds like an interesting pattern, but who is building real world enterprise grade applications in that realm? Who's using these kinds of constructs like serverless and consumption based pricing to build enterprise grade applications? Well, I want to show you a quick example. This is a chart that you may have seen, and just look at the hockey stick growth. Back in March, Teams usage was around 32 million active users. In April, it reached to about 75 million active users. So you're looking at this chart and saying, yeah, that sounds great, but every collaboration remote meeting tool is growing at this pace. So why are you talking about this? Well, I'm talking about this because of this slide. Teams, whether some of you may be using it, some of you may be using some other tool, Teams uses the kinds of services that I was talking about earlier, which is all the serverless kinds of things. It uses Kubernetes, it uses Cosmos DB, it is using Redis Cache or Service Fabric and things like that. And look at the chart on the left-hand side of the screen, where because it was built on these cloud native constructs, they were able to quickly scale this application up. Going from 35 million to 75 million within a span of 30 days is quite an incredible story. So the point I'm trying to make through this slide is that use of serverless technologies together is leading up to really significant enterprise grade applications, and having 75 concurrent or active million 75 million active users is a pretty significant uh, number by any measure. Okay, so moving on, the next thing I want to talk about the developer productivity. So it's great to have serverless, it's great to have consumption pricing. What about developer productivity? What are the kinds of things that we should be thinking about? So first and foremost, when we talk about Azure or when we talk about the Microsoft Cloud, we are not just talking about Azure. And as we go through the presentation, you'll realize this, that it is really the confluence of three clouds that are giving us this hyper productivity kind of experience. So it's the Azure platform which powers it all. And then on top of that, you have the Power Platform, which is the low code, no code platform. And I'll give you a little hint. So there's a lot of talk about low code, no code, and there's a lot of talk about citizen developers building applications and not having a need for professional developers necessarily to write all these applications. And that's certainly true. Power Platform has enabled citizen developers to dip their toes into the world of building applications. But I'll give you a little tip. Uh, I see many professional developers dipping into the Power Platform because they're able to crank out applications at a much rapid clip than they would if they were using the traditional tools. So I want you to take this important lesson away. When we talk about productivity, we're talking about low code in the context of professional developers as much as we are talking about the citizen developers. Okay, so Power Platform, Dynamics 365, you're building an application for a customer. Maybe you want a single view of the customer. Dynamics could be great. You don't want to create this up from scratch. And then, of course, we have the Microsoft 365 or M365, where you have the whole collaboration platform. You have the Teams platform, where you can embed Power Platform applications. So you can do all kinds of things to very quickly build these kinds of applications. So moving on, here is a typical application. We have Power Apps running inside Teams, so you can just build a low-code, no-code application and snap it into a Teams tab, which in turn calls API management. Teams can call an Azure service. It'll call an API management, and then API management can in turn call a microservice hosted in Azure Kubernetes service, and that Kubernetes service can then in turn talk to Cosmos DB. And there are all kinds of interesting things there related to the Kubernetes community doing things like the service broker, which automatically brokers a connection to Cosmos DB. So you are within the cloud native constructs essentially. The next thing I want to talk about here really quickly is the data platform, right? You just cannot have this application generate a lot of data and not have good tools to analyze this data. What do I mean by that? So on the left-hand side of the screen, you have data coming in from your on-premises application. Maybe you have some SaaS services. Maybe you have some IoT story, what have you. You have all of this data coming in, and then you now want to analyze this data. And once again, the concept of serverless and consumption-based pricing applies here as well. And this is sort of the important thing to take away from this slide. So you bring all of this data, you store it some sort of a data lake, and then once you have the data in the data lake, you can now process this data using a relational data warehouse model, which is the SQL pool capability, previously known as the Azure uh, data warehouse. Azure SQL DW is now called the SQL pool capability. So you have this data coming in into some sort of a storage data lake, and now you want to run uh, some sort of an analytic query in a relational model where, well, you're not paying for any SQL compute capability. If you don't want to, you can use something called the on-demand pool and just run your query, and your analytics query is running, and you're only paying for the time that analytics query is running. Okay, that's one part of Azure Synapse, right? You may have data which does not lend itself to a relational warehouse technology, and you really need to process it using some sort of a Spark script. Well, Azure Synapse combines the two models of analysis. So on one hand, you have the relational model, and on the other hand, you have a Spark pool available. So all the goodness of Spark is available to you, right? So both these models can be brought up, can be elastic, can be on demand, and can be consumption based pricing. So I want to make sure that our theme of all the way of building application in a serverless consumption model continues all the way down to data analysis. The last two things I want to talk about in this slide is, of course, Azure machine learning. Azure machine learning is, again, uh, it can be connected to the same data lake. You can run a training algorithm. And once again, in the same model, in this case, you might be running a deep learning net algorithm. And that deep learning algorithm may require some GPU compute versus a CPU compute. You can now train your model using a GPU compute, pay for the time you're training it. And once you're done training, you can get rid of the GPU compute. You can take your trained algorithm, containerize it, and run it inside another consumption-based pricing called ACI, or the Azure Container Instances. So you see where I'm going with this, that if we think about this whole model, we can have the richness of the platform, the productivity of the platform, at the same time have a lower total cost of ownership. Okay, so that's the Azure Analytics part. So with that said, I wanted to quickly show you a very simple application, and I'm not going to get into as much detail because there are lots of sessions to go into the details. My goal here is really to motivate the things that I talked about. As a developer, I always like to have some code working to sort of bring home the point, but we will very quickly just go through this model, and then let's see, maybe, and leave some time for questions if there are any. So I have a simple reference application, and two of my colleagues, Gaurav Mantri, some of you may know him, and Vamsi, this application was really put together in the last 48 hours because I thought it would be good to have an application. So I wanted to thank them, call them out. Here is what the application does. So we have a trip tracker application, very nothing fancy, very simple application. So I'll walk you through this application right here, starting here. So first thing we wanted to do is we wanted to have a mobile application that works across all mobile platforms. And this is where Power App shines. So we built a Canvas app, which can then be deployed to iOS, Android, what have you. So built a Power App very quickly, within hours, literally, to build a Power App. That Power App calls uh, an Azure function, and we'll take a look at the code. And what in this case is happening is, when, let's say, I'm an Uber driver, or I'm a taxi driver, I start my trip, application comes, my mobile app starts sending GPS coordinates, right here, starts sending GPS coordinates to an Azure function. This function is HTTP triggered, so I'm only paying for the times that is coming in. The Power App calls the Azure function. The Azure function then in turn writes it to Cosmos DB, and then right here it goes into the Cosmos DB. There's another Azure function here, which is triggered by the Cosmos DB change feed. So you may be familiar with the change feed, a very powerful model. All the things that are happening in a Cosmos DB instance are available to you in the form of a change feed, where you can do some processing on that data. So we have another Azure function. So this first function is triggered by HTTP. The second function is triggered essentially by the change feed. So once we write to a Cosmos DB instance, this Azure function is going to get triggered. This Azure function is then going to use SignalR to essentially send an update back to an administrative app. So here's an administrative app which can see where my taxi drivers are, and then they can essentially look at that data. So pretty simple model, but at the same time, not only is it simple, it has two other characteristics. Let's just talk about this for a moment. So it's a pretty simple model, but I'm of course paying consumption pricing. But at the same time, I have, so what happened here? So I'm not sure what just happened. Okay, I'll keep, please tell me if you can see this. The screen suddenly changed on me a little bit. Hopefully you can see it. Okay, I'll assume
Yeah,
that.
Vishwas, we can see it clearly. It's
Okay,
fine.
very good. Thank you, Stephen. Just something happened, and I just wanted to make sure you're able to hear me. Okay. So very quickly, the point I was trying to make here was, all these pieces of code uh, are, as I mentioned, they are serverless model, but at the same time, we have sort of outsourced the underlying complexity and the resilience. So what do I mean by that? Let me just explain this point a little bit. So because we are writing to Cosmos DB, Cosmos DB is a geo-replicated database. If we have lots and lots of new drivers show up, all we have to do is, it's really up to Cosmos DB to scale up and down. It's not our responsibility. And let's say we have to spin up this application in more than one region. We can have a geo replication turned on. So we really have outsourced the underlying complexity of scalability and resilience. Same thing with the Azure functions. If more load comes in, we are not in the business of writing auto scale logic. Somebody else's job it is. We just give them a range, they scale us up and down. Okay. And similarly with the websites here, since this is a single page application, this can be hosted inside the static websites capability that Microsoft just announced. And the idea is you're really not paying for a web server because the entire code can be on inside a CDN, if you will, and all of the dynamic aspects of the code are really some JavaScript and the signals that are coming in here as part of that. So this may seem like a toy application, which it is. It was built in a few hours, but it at the same time exhibits the characteristics of an enterprise application in terms of scalability, resilience, and things like that. Okay. So with that said, let's go over and just take a quick walkthrough of this. Let me start out with, and we will make, what I'll do is after the session is over, I'll tweet the link to this code so you can spend more time looking at it if you like to. So the code is not very interesting, I have to say. Let's just see a couple of things here. So this is the trip tracker function. This is where our Power App is going to be, when HTTP trigger comes in, our Power App will come in here. We capture some data and we simply write it to the Cosmos DB service. Okay, nothing fancy going on here. Let's look at the other Azure function right here, which is going to be triggered when the change feed triggers, okay, right here on line 15. And when that triggers, all we are going to do is do an add async for SignalR right here, which will then communicate with our administration website and update the location of that taxi driver or an Uber driver, whatever. Okay, so those are the two important pieces of code right there. And then here's some code which basically essentially sets up the SignalR right here. If you go up here, this is where we are setting up SignalR. This is the startup.cs code. And this is, of course, in the function app startup code. This will enable the SignalR. So pretty simple code base. I'm just trying to look at anything else I want to show here. There's some simulator. Of course, let's just look at the admin website here very quickly. So you can see the admin website. These are all the pieces of code, not very interesting right here. You can see it's essentially a single page application that can be hosted inside the static websites. Okay, so since I'm going to go run out of time very quickly, so let me just also show you this application in action. And so what I want to do here is I'll come to my resource group in a minute. All of the resources for that entire application are inside this one resource group. So uh, we have the app service, we have the consumption plan where our Azure functions are hosted, we have a bunch of app insights, we have Cosmos DB, and we will go into this a little bit. We have a Cosmos DB instance, and there's a capability within Cosmos DB uh, called the Synapse link. And remember when I was talking about Synapse as your way to analyze this data, where inside Cosmos DB, we have something called Synapse link. We can go into Cosmos DB and establish a connection so that that data is automatically transferred into an analytic store. So all of the hard work and error prone logic that we had to write in ETL code is sort of greatly simplified by having that Synapse link. And I'll show that to you in a moment. And then I also have the Key Vault, of course. Uh, I have the machine learning service. We will go into that. Once we have collected the data, once we have done some analytics, we can also do some machine learning on that. Then I have the SQL pool. This is what I was talking about, where I can run my analytics. I have a bunch of storage accounts, of course, that you would expect. And here are the two Synapse workspaces that I have, essentially. So uh, not a trivial resource group in terms of all of the capabilities that are there. Okay, so let's just go over here. Let's start our application right here. And this is, of course, a very simple application here. And I can do one thing here, which might be interesting for you all to look at. Of course, this app can run inside iOS or Android or whatever. I just turned on the developer tools part just to point out one interesting thing here. Let's just go over here for a second. So I can come here, right here, you can see, let me escape out of this, and you can see here that what this application will render on a Pixel, what will it render on iPad X, and so on and so forth, right? So that's the beauty of the Power Platform, that you are writing essentially code which is very similar to an Excel macro, and you are dragging and dropping these widgets, and under the covers they are taking care of making sure your application can be hosted across all of these platforms. Okay, so I just wanted to quickly show you that. And so that's our application right here. Let's start our trip. And if I start my trip here, let's see, we'll give it a moment here. So it'll start sending data to the Azure functions, which in turn will trigger our second Azure function, which in turn will trigger the SignalR code. So if I go into my web app here, web administration application right here, you can see that my chart is moving here. This is our the static websites code that I talked about. So it is receiving signals from the SignalR service, updating the coordinates on the map, and as our trip is progressing here. Okay, so just imagine the productivity difference if you had to build an application. Uh, this was literally a couple of hours of work. I almost toyed with the idea of building this app during the keynote, but then I said maybe that'll be too much. But literally two buttons and a timer control and really a data grid here, and then about 10 or 20 lines of uh, formula like code, which in turn calls the HTTP trigger for my Azure functions. That's literally what this code is all about. And this code right here is pretty simple, a single Google map with SignalR coordinates coming in, and we are updating it here. And then see the taxi stopped moving because I stopped the trip here. Okay, so that's one part that I wanted to talk about. Let's just now go back to our resource group here. And I just wanted to call out a couple of things. We can come in here. So this is the app service plan. This is the app service right here. And this is where our admin interface is hosted right here. So that's pretty easy to understand. I did promise you that I'll show you the Cosmos DB part and the link part. So let's just go over to the Cosmos DB. This is a brand new capability and really exciting here. This was part of the keynote actually, if you watched the build keynote. And let's just go over to the document explorer. Open the document explorer. And I have two databases essentially. Let's just go in here and just let's look at the properties of this guy here. Let's look at the properties. And if I go further down here, and right here, you can see analytical storage is turned on. That's all you literally need to do to send your OLTP information. So drivers are sending this information in real time back to Cosmos DB, and this information is getting automatically transferred over the Synapse link, converted into a columnar format, which is conducive for analysis. So now, if you wanted to do some analysis on this data in real time, not last month's data or last week's data, but if you wanted to do real time analysis inside Synapse, you can just spin up a Spark pool or a SQL pool and start analyzing this data. How many trips are happening and what is the average price? Do you need additional drivers? You can take these decisions really, really quickly. This was easily, having worked on many projects related to ETL processing. I can tell you that the error prone process, this way of taking your data, converting into columnar format, conducive for analytics, is a big step forward. So I just want to show you this right here. Okay, so that's one part. So that's the Cosmos DB part. I'm trying to see. Let me also show you here. Let's see if I can bring up the Synapse, one of the Synapse workspace here. So looks like it's waiting for this refresh to happen. But what I was going to essentially show you here was all of the essentially a couple of examples of queries that I was performing against the relational database. And looks like it's not showing this up here because of an RBAC issue. That's okay. Uh, I will send you a screenshot or a tweet a screenshot. I was not going to run this query, but really the idea here was that I was going to take New York Taxi Service publishes a lot of historical data. And what I did was essentially took 50 gigs of that data because my app is not generating that data, of course. So in so took a 50 gigabyte set of data set from that New York Taxi Service and brought it inside the Synapse Studio and then run a SQL query against that. And it's pretty powerful to see that those queries can be run within seconds without really having built a canonical OLAP model or something like that. So that's a really powerful capability. Okay, so the last thing I want to show you here is, of course, the machine learning piece. So now that we have the data all available to us, we have performed some analytic queries, we have given our line managers some information that they can go into a decision-making process. I can now come in here and within the same data, so I'm not moving the data anywhere, it is still in the data lake, or in this case specifically Azure Data Lake Gen 2. Now I want to do some analysis of what are the factors that lead up to higher trips on any given day. Is it the number of drivers? Is it the placement of the drivers? Is it the timing of the drivers? If I want to figure it out, if I want to do a predictive analytics around that, this I can do. So once here, I'm inside machine learning workspace right here. And I know I'm going through lots of services, so I'm trying to be a bit slow about it and not overwhelm you with too many tabs. But think the key thing to take away from my presentation here really is that uh, these are the capabilities available, and then on your own time you can then go into each capability and explore it for your own scenarios. That's my hope here. So in this case, I have a Python workbook right here, uh, which loads the data from our data lake Gen 2 architecture. It is processing them some data. As you well know, in order to run machine learning algorithms, you need to cleanse that data. Oftentimes, you need to vectorize the data so that machine learning models can pick it up. So all this workbook is doing some cleaning. It is doing some transformation. So converting lat long into some real street names and whatnot, so we can get a better sense here. And then once the data processing has been done, then I can show you the other workbook right here, which is going to do some regression analysis on this data to figure out which features in this data set were most impactful in determining how we can maximize the number of trips. So we are taking predictive analytics into account. And once again, I can run through this code and certainly see I see an error here because when I started running this just a minute or two before the keynote started, my compute instance was not running at that time. It is running. So once again, going back to our theme, I need the compute instance only while I'm inside this, when I'm running this algorithm. And once I have trained this algorithm, I can containerize it, put it on Azure container instances, and I really don't need that compute at any point after that. Okay, unless I have to, of course, retrain my algorithm or change some hyperparameters or something like that. I really don't need that compute available back to me. So let's go back to the slides here really quickly. So we have come essentially a full circle, right? We have shown a Power App, which we really built using drag and drop and using controls that work across the platform. And I showed you very quickly that you can, without having all the devices available to you, I gave you a little trick of how you can test your Power App against all of the different form factors, quickly build that application. That app is then connected to Azure Functions, which is nothing but an HTTP triggered in our case, which in turn stores data inside Cosmos DB. And inside Cosmos DB, we had an Azure Synapse link, which was sending the OLTP data into an analytics store. So we can do some analytics on top of that. And the real scale of this architecture comes by decoupling. So one function is writing to Cosmos. Cosmos is sending data to Synapse. Another function completely decoupled, and that's really the hallmark of a scalable architecture, that you have things decoupled. The other function is waiting for a Cosmos DB change feed, gets a change feed, and then we are not making our administrative interface load and load again and do refresh or anything like that. We are pushing that data out or a WebSocket or something similar to our open browser connection and making updates. Imagine you have hundreds of cars running. You don't want to be expensive in terms of refresh and things like that. And then once we had the data in the analytics store, we could run a Spark query, or we could run a SQL query. And then we could also run some sort of a regression analysis on that data to do predictive analytics. So in a sense, we have tried to achieve the three objectives that I had laid out. And I usually like to do this. I like to go back to my agenda slide at the end of my session, always, because, did I hit on the points that I really had promised that I will hit on? So cloud native constructs, so serverless programming model, uh, not having to worry about patching and underlying OS upgrades and having to worry about multi-tenancy and things like that, or writing complex auto-scaling algorithms. We achieved that through a combination of services that we talked about. Did we achieve consumption-based pricing? Well, we did. We were using Azure Functions. We were using Cosmos DB. Now, Cosmos DB, we're using the free tier of Cosmos DB, and Cosmos DB team has announced a consumption-based pricing later this year, so watch for that. But other than that, every other piece, all the way up to machine learning, was on a need basis only. And then did we achieve the developer productivity? Well, we built a multi-platform, multi-form factor application using Power Apps, low code, no code ability. We use Synapse Link to reduce our ETL time, and then we can use some of the pre-packaged. I didn't get a chance to go into that. That in I was showing you an example of regression analysis that I was conducting, but you may have heard of this in cognitive services, that there is a new capability called the personalizer service. Some of you may have heard of that. It's essentially, and in fact, they announced something called the apprentice mode for the personalizer service. So you really didn't even need to write that custom algorithm. You could essentially feed your data to the personalizer service, and it is based on an RNN model, a reinforcement learning model. So it can get that data and it can start giving you decision choices that you can make based on that data without having to create your own ML workspace and things like that. So we are also taking advantage of the developer productivity in the process. Okay, so that brings us to 10:58, which is about a minute left in my uh, keynote. I was told to go until 11. So Stephen, Mahesh, Magnus, uh, back to you guys.